We use these apps every single day. Apps that handle our money, our health, our most private information. But have you ever stopped and wondered what is really going on behind that screen? Well, today we're going to do something a little different. We're actually peeling back the layers of a financial service called PayCal, and not just by looking at its flashy features. Nope, we're digging right into its source code to see exactly how they build a digital fortress to protect you and your money.
It's the question, right? It probably pops into your head every time you log into your banking app. You hit send and your most sensitive info. I'm talking salaries, social security number, the whole shebang. It just goes flying out into the internet. But what happens in that split second? Where does it even go? And maybe more importantly, who's watching it?
Well, today we're getting some real answers, because you are coming with me on a guided tour of a real-deal digital fortress. We're going to explore its impenetrable gates, we'll meet its tireless guards, and we'll even get a rare peek inside its most secure vault. And the best part? This isn't just theory. This is all based on the actual architecture of a modern, security-first application. Okay, so here's our tour plan. First up, your unbreakable front gate, basically how you get in. Then we'll meet the guards on constant patrol. These are the active systems watching your back. After that, we're venturing deep inside to the zero-knowledge vault where your data lives. And finally, we'll see how the whole thing runs on privacy by default. We've got 4 layers to cover, so let's jump right in at the most logical place, the front gate.
So our tour begins at the most critical point of any fortress, right? The entrance. In the digital world, that's your login. And for decades, let's be honest, it's been the weakest link. It's been a constant source of anxiety and data breaches. But all that is finally starting to change.
So the key to this huge shift is a technology called Passkeys. And this isn't just a better password. It's a completely different way of thinking. It's backed by all the big players, Apple, Google, Microsoft, through this group called the FIDO Alliance. See, a password is a secret you have to remember, something you can forget or get stolen or, share. A passkey is a unique cryptographic key that lives only on your device. Think of it like this. A password is like knowing the secret knock to get into a club. A passkey is like having the one single uncopyable key to a bank vault. And this comparison just makes it so clear why that difference is massive. With old-school passwords, if a company's server gets hacked, poof, your password can get stolen. A scammer can trick you into typing it on a fake website. And we all do it. We reuse them. Passkeys just solve all of that in one go. Because the key never leaves your device, it can't be stolen from a server. It's also cryptographically tied to the real website, which makes phishing pretty much impossible. And since every passkey is unique for every single site, a breach over at one company has zero effect on your security somewhere else. It's not just an upgrade, it is a total game changer for how we prove who we are online.
And for Passkey, this is not just some surface-level feature they tacked on. We can see it right here in their own source code. They have 77 separate files dedicated just to implementing and supporting Passkey technology. That is not a feature, my friends. That is a foundational commitment to building the strongest front gate you can possibly imagine.
So, you've used your uncopyable passkey, you're through the front gate. You're in. But security doesn't just stop there. Any great fortress needs active defenses. It needs guards on the walls, constantly looking for trouble. So let's go see who's on patrol. The second your session is active, PayCal deploys a whole team of automated digital guards. Now, these aren't people, obviously. They're specialized security systems, and we can see them outlined in their engineering plans. Each one has a super specific job to do in real time, all to keep your session secure from the moment you log in to the moment you log out. All right, let's meet the team. First up, you've got the Content Security Policy, or CSP. Think of this guard as the bouncer at an exclusive club. It checks the ID of every single piece of code that tries to run on the page. If it's not on the approved guest list, it's not getting in. Simple as that. This just shuts down a whole category of attacks. Next, there's the Runtime Integrity Monitor. This is your security chief. It's constantly watching the application's core code, and if it detects any tampering or anything that looks seriously wrong, it has the power to lock the whole system down to keep you safe. And finally, you've got the Guardian Sanitizer. This guard's job is to inspect every piece of data right before it shows up on your screen, scrubbing it clean to make sure there's no hidden malicious code trying to fool you or your browser. Okay, so we've passed the gate and we've met the guards. Now, we're heading to the very heart of the fortress, the vault. This is where all your financial information, your pay stubs, your tax documents, is actually stored. And this vault, well, it has a very, very special property. It's built on this pretty radical principle called zero-knowledge encryption. And here's what that means, and this is wild.
PayPal builds and maintains the vault, but they have absolutely no way to open it themselves. They are essentially mathematically blinded from ever seeing what's inside. The best analogy is a mailbox with a special lock that only you have the key for. PayPal can deliver mail to the box, they can guard the box, but they have zero way of opening it to see what's inside. The only person on Earth who holds the key to decrypt and read your financial data is you.
So you're probably asking, okay, how is that even possible? Well, it's this brilliant multi-step process we can see laid out right in their code. Think of it exactly like a high-security bank safety deposit box. When you log in with your passkey, it doesn't just unlock your data directly. No. First, it generates a temporary key, what the code calls a key encryption key, or a KEK. That KEK has only one job, to unlock a tiny, secure box on the server. And inside that little box, that's where your real key is, the data encryption key, or DEK. It's this final key, the DEK, that actually decrypts your financial info so you can see it. Since PayCal never ever sees or stores that final DEK, they can never ever open your box.
And look, this isn't some secret magic they just cooked up in a lab somewhere. The security index in their source code shows this whole system is built on something called AES 256 GCM encryption. Now, to put that into perspective for you, this is the same gold standard the US government uses to protect classified information. It's been publicly vetted, it's battle-tested, and it's trusted by security experts absolutely everywhere. But what happens to your data once it's decrypted so you can see it on your screen? Well, PayCal's engineering plan includes this really cool process called zeroization. The best way to think about it is like a digital paper shredder. The absolute instant the data is no longer needed on your screen, the decrypted version gets forensically wiped from the app's memory. No traces, it's just gone. There's nothing left behind for anyone or any malicious code to find.
Okay, for the final stop on our tour, we're looking at a different kind of protection. We've seen how PayCal keeps the bad guys out and how they lock down your data. Now let's see how they protect your privacy from themselves.
Okay, let's be real. To improve their service, every app company needs to know what's working and what's breaking. They do this by collecting data they call telemetry, but there's a right way and a very, very wrong way to do this. And the PayCal approach, which we can see right in their transparency reports, is to make it completely anonymous by design, right from the very beginning.
And this table shows you exactly what I mean. On the left, this is the raw data they record, and it's taken right from their documentation, passkey.login.failure.17. Now look at the right. This is all they learned from it. There were 17 anonymous failed login attempts today. That's it? Notice what's missing? Your name, your user ID, your IP address, your location, absolutely nothing that could ever be traced back to you as an individual. And hey, don't just take my word for it. They state it publicly, plain as day, in their transparency report. I'm going to read it directly. Only operation counts are recorded. No key material, ciphertext, or personal identifiers are stored. I mean, that is the literal definition of privacy by design.
So let's just quickly recap our tour of this digital fortress. We've seen that your front gate, your login, can actually be your strongest line of defense with passkeys. We've met the digital guards that are always on patrol, actively protecting your session. We discovered that your data can be kept in a zero-knowledge vault that not even the company that runs it can access. And we learned that real privacy isn't some checkbox in a settings menu. It's a fundamental part of the core architecture.
You know, the reason we went on this tour, the reason we dug into the code, it isn't just to talk about one single app. It's to see a blueprint. This whole multi-layered approach, a strong entry, active guards, an unbreakable vault, and total respect for privacy. This is a model for how any modern service that handles our sensitive information can, and frankly, should be built.
And that leaves me with one final thought for you. Now that you know what's possible, now that you've seen inside a true digital fortress, it kind of makes you ask a new question, doesn't it? Shouldn't our banks, our healthcare providers, all the services we trust with our most private data, shouldn't they all be held to the same standard? Now that we know what's possible, shouldn't we demand that they're all built this way?